I'd like to go over some nonlinear systems of equations using exponentials and logarithms and show you some connections between those two and how we can use rules for logarithms to solve these. So consider an exponential decreasing function like this, where it decreases at time 1, there were 400, the value was 400, and by time 5, the value had decreased to 100, and it's decreasing exponentially. So we have a formula along these lines where we have A is the initial value, which we don't know in this case, and B is the growth factor, the periodic growth factor. Every time you increase by 1, you multiply by B. Or in this case, B is less than 1, so you decrease by a factor of B. How can we set up two nonlinear equations to solve for A and B? The idea in this case is we have two unknowns. We don't know the parameters A and B. So we have 2 points that we can plug into that equation and find, then the remaining unknowns are the parameters. So we have, when x is 1, we have a y value of 400. When x is 5, we have a y value of 100. So that gives us two equations, nonlinear equations, because b is to the 5th power in one of them. So we've got powers of the variables, and they're multiplied together as well. So that's not a typical linear equation. But we can solve these, and there are multiple ways we can go about and solve these. You just have to follow your knowledge about algebra rules. We can do substitution, and that's what we'll do here in a second. Elimination doesn't work because you can't add and subtract these equations like you do linear equations. But let's do substitution, and we can substitution. So solve for A in the first equation. A is equal to 400 divided by B. And then we can take that and substitute it in for A. And so what happens when we do that? We get 100 equals 400 over B times B to the 5th. That's what the equation said. We plug that in. And then we simplify. And now we can solve using whatever method we want. So 100 over 400 equals B to the 4th. We can cancel the B to the 5th divided by B, and we get 1/4 equals B to the 4th. We have our variable to a power, so the way we can solve that is by taking the 1/4 power of each side, and we get 1/4 to the 1/4, which is B. And 1/4 to the 1/4, you can do it on a calculator, or you can think about it as the 1/4 power is the square root of the square root. And so you end up getting the square root of 4 in the denominator. But if you just do it on your calculator, that comes out to something like 0.707, okay, approximately, right? So B is, the growth factor is 0.707. And then we can find A. A was supposed to be 400 over 0.707, and that comes out to, I think, 526, or close to that, okay? So you can also, so if you go back to our graph, that means that the y value is going to be up here around, and we figured out that's 526 or so. You can also think about that as when you increase by x by 1, you multiply by 0.707, right? When you increase by x by 1, you multiply by 0.707. When you decrease x by 1, when you go from this point back from x equals 1 to x equals 0, you divide by 0.707, which is what we did in the algebra, and we got 526. So that seems to work. Let's look at this in a different way, though. I want to do this by taking the logarithm of both sides. We have exponential equations for this, a system of two exponential equations. And so often taking the logarithms makes that linear, makes that simpler. And so let's take our original equation, y equals a times b to the x, and take the log of both sides. And we're going to get two linear equations, but the variables are going to be, I'm going to call them w, which is going to be equal to the log of a, and v, which will be equal to the log of b. So a and b are the things we don't know. But when we take the logarithm of both sides, you'll see in a second, we get the two equations in terms of log of a and log of b. So let's just call those different variable names w and v for a second. So if we have the original equation, which is y equals a times b to the x, we can use our rules for logarithms, and the logarithm of the left side is log of y. Then the logarithm of, there it's written at the top, the logarithm of a times b to the x is just the logarithm of a plus the logarithm of b to the x. But we can bring that exponent down in front and make it x times logarithm of b. And so when you do that, now it looks, that's the general form, and now we can plug in our two data points. We can plug in y is 400 and x is 1, and we get log of 400 equals w, which is the log of a, plus 1 times v, which is the log of b. And so then we can plug in our other value, and when y is 1, we get the log of 100, and x is 5 in that case. So we get a log of 100 equals w plus 5v. Now we just ask our calculators what are the actual values for log of 100 and log of 400, and it turns out log of 400 is 2 to the 6th, because 10 squared is 100, and 10 cubed is 1,000, and 400 is in between those two things. So the exponent here will be between 2 and 3. It turns out it's 2.6. And so we get a system of equations. We get this box of systems of equations. And now it's just a linear equation with variables v and w. And we can solve that. And so I chose to solve that. You could do it by substitution or elimination. I chose to solve it by subtracting row 2 minus row 1. So I have 2 minus 2.6 is negative 0.6. The w's cancel out, and I get 5v minus v is 4v. So when I'm all set, I have my, I have that equation for v, and I can solve for v, and v is negative 0.15. And then I can solve for w. Since w plus v is 2.6, w has to be 2.75. But those weren't the variables I wanted. I wanted a and b. So how can I change back to a and b? Well, I use my relationship between a and b and w and v. And if w is log of a, then a is 10 to the w, and b is 10 to the v. And 10 to the 2.75 is 562. The same answer we got for the a in the original case, when we did exponential equations. And b is 10 to the negative 1.5, or negative 0.15, and that ends up being 7.707. And that it really is square root, or 1 over square root of 2. But we can, in this case, we rounded, and the calculator, we rounded when we got the 0.15, and so the calculator is off by a little bit. But the fascinating thing about this with exponential functions is we have two parameters, and we can solve if we have two values given. But if you take the logarithm of both sides, you get linear equations in terms of the parameters given. And so you can solve using elimination or substitution or whatever you wanted, and that works just fine. One last note about the connection between these two methods of solving these problems. Let's look at this on the left as the two equations as logarithms, and on the right, we'll look at the two equations as exponentials. When we solved as logarithms, they were linear equations in terms of the logarithm values w and v, and we were subtracting rho 1 minus rho 2. And if we do that, we get this equation. Compare that to, on the right-hand side, when we're doing exponential functions, if we have two equations, the 100 equals a times b to the fifth, and the 400 equals a times b, we can divide those two equations, much like we subtract them in the other case. And if we do that, we get this situation: 100 over 400 equals a times b to the fifth over a times b. And just like the w's cancel out on this side when we did when we subtracted those two equations, the a's cancel out on this side when we divide those two equations. And so we get the logarithm of 4v equals, the logarithm of 100 over 400 equals 4v. That is analogous to 100 over 400 equals b to the fourth. And we had b to the fifth over b. That's exactly, we subtract exponents. 5v minus 1v is analogous to b to the fifth divided by b, we subtract exponents. And so when you change back at the end, we end up with 100, we change that back into an exponential form, we end up with 100 is 10 to the 4v, which is 10 to the v raised to the fourth. 10 to the v is just b, because that's how we set up, how we define v to be the logarithm of b, so 10 to the v equals b. And so these two equations are exactly the same thing. One is just done in the logarithm form, where you subtract logarithms, and then the other is done in the exponential form, where you're dividing exponents, so you're dividing exponentials, so you subtract their exponents. And everything cancels out the same way. Just in one case, it's kind of in a subtraction way with the logarithms. The other case, it's in a multiplication and division way with exponents. It's very cool how they connect.